I hope all of you seen my my PowerPoint presentation, generalization and specialization.
Yes, sir. Yes,
Is
sir.
it okay? So this slide I already discussed in my last class or yesterday class, but still I can just start from here. Just a quick review of that. The generalization and specialization. That is generalization and specialization. Both are uh, synonymously used. Uh, One is the bottom-up approach, that is the generalization, where combining the number of entities set that share the features of means lower level entity set that share the features of the higher level entity set. And specialization is the bottom-up approach, top-down approach, where the from higher level to lower level, it is a subset of subgroup or subset of within the entity set that are distinctive from the other entities in the entity set. Uh, Basically, the main thing is the lower level entity set, and there is a lower level entity set and higher level entity set. In lower level entity set, for example, here account is the higher level entity set. This is the uh, just a minute. This is higher level entity set, and these are the lower level entity sets. Okay, so here lower level entity sets have the some features from the borrowed some features from the higher level entity sets. That is from lower level and upper level, and as well as the among the lower level, there is some commonality is there. For example, the saving accounts and checking accounts both are the entity sets. These are the lower level entity set, and both of these entity sets share the some common features. What are the common features? Account number and balance, and these are actually comes from the higher level. These features actually comes from the higher level entity set account. Although account number and balance, other than saving accounts, consist the another attribute, interest rate, whereas the checking accounts contain the another descriptive attribute, that is the overdraft amount. Okay, so whatever actually I told, the specialization and generalization are simply inversion of each other. That is the one is the top down and there is the bottom up approach, and they can represent in the ER diagram by this triangular shape is a. I give you another example here also. The faculty, the faculty is described by the employee code, employee name, employee address, employee phone number, and so on. Say phone number and so on. Okay, this is the higher level entity set, and these are the lower level entity sets. Say professor, associate professor, assistant professor. They have might be some different attribute. Okay, along with the common attribute, those present in the faculty entity set. That is the employee code, employee name, address, phone number. That is these four attributes: e-name, e-code, address, and phone number. These four attributes are actually common in professor, associate professor, and assistant professor level. Along with these four attributes, there may be some other descriptive attributes are there. Okay. We may consider the suppose the another example. Suppose say sorry. Suppose the uh, suppose the entity set car. Say car. The car have the number of attribute. Say this is the vehicle ID. . say vehicle ID, say number of say passenger. Okay, maybe maximum speed, say max speed. Okay, maximum speed. Say the another attribute, say price. Okay, that is car. We can consider the car is the one of the attribute. How this one of the entity set or object. How this object or entity set described by the number of attributes: vehicle ID, maximum speed, price of the car, number of passengers, maximum carried by this car. Suppose the another entity set, say, for example, say, consider say truck. Okay, the truck. What is there? The attribute say price. Okay, say attribute vehicle ID. Okay, say another attribute, say number of axles. Okay, say load capacity. Maybe some other attributes are there. Okay, so by these two entity set, they are distinct. You can see here some common features are there. What are the common features here? Please tell me. From this figure, I think it is clear. What are the common features or common attributes? In both of the entity sets are actually distinct.
Number of passengers.
Trace, vehicle ID. The number of passengers in case of truck, it is not the more appropriate. More appropriate in case of truck, the load capacity, I think, or maybe the number of axles to carry the higher load. But in case of car, the number of passengers is the important. It is a 5-seater or it is a 7-seater, or it may be a 20-seater, or it may be a 50-seater bus or like that. Is it? But in case of truck, actually, rather than the number of seats or number of sitting capacity, their important is the how much load, say 500 ton or maybe the 1000 ton, how much load actually carry by the truck. But here some common features is there. You all correctly told, that is the vehicle ID, price, and so on, and as well as the say here the maximum speed is the another. Here also there in case of truck there is a maximum speed is there. Okay, so this is the other attribute. So these common features in both the entity sets we can represent by a generalization or maybe in a specialization. So if we consider, say, think one of the entity set, that entity set actually consists of common features, say vehicle ID.
Sir?
Please tell me.
Sir, why can't we say number of passengers is a common feature for both?
Now, in case of truck, I am not right in the number of passengers. Please see the attribute of the truck. Attribute of the truck, I have written the in place of number of passengers here. Attribute is the load capacity. The number of passenger is not important in case of truck. Is it? No? Number of passengers are important in case of truck or lorry. Yes or no?
No, sir.
Rather, number of passengers, their load capacity, how much load actually carried by the truck. 100 ton, 500 ton or 1000 ton, what? That is the important factor there. Okay. So for that, in case of truck, if you see here number of passenger is not the attribute. So in both of the case, what are the common attribute? Vehicle ID is there, price is there, maximum speed is there. Say max speed. This is the another attribute. Okay. What I write inside them is A. Okay. This is the generalized. Is A. And these common features have or by the car, and as well as the by the truck. Is it okay? By the truck. Is it not? Car consists the vehicle ID. The display part is a problem. Car consists of vehicle ID, price and maximum speed, as well as the truck also have the features vehicle ID, price of the truck and maximum speed of the truck. Okay. So instead of this, here in case of car, there is another attribute is there. What is the attribute? In this example, number of passenger. Is it? Number of passengers. And in case of truck, there is another attribute, load capacity. Okay. Both the attributes are different. So this is the generalization. If you think bottom-up approach, then this is a generalization. If we think top-down approach, then it is a specialization. So this higher level entity, suppose we give the name of this entity, say vehicle. Okay. So what happens here? By this, the car and truck are the two lower level entity. These two lower level entity sets have some commonality is there. What are the commonality? This commonality actually is the vehicle ID, price and max speed. That is the features of the higher level entity set vehicle is shared by both the lower level entity set car and truck. Although there is some different descriptive attribute may be present. I think,
sir, is the given
there any
diagram
question?
generalization or specialization, sir?
Is the
Sir, in the given diagram, if we are going from top to down, we are doing specialization, right?
if you think like this division from top to down, then this is a specialization. Okay. If you think like a bottom-up approach, then it is a generalization. Okay. Both are actually same, just like a inverse.
Okay, sir.
Main thing is there is some common property is there. That common property is shared by the lower level entity set from the higher level entity set. Okay. Here another example, suppose the person. The person have the attribute name, street, city. Okay. The person may be employee and maybe it is customer. Okay. Suppose if we consider the banking database system, the person, so employee have the name as well as the address, city of that employee or street and so on, and maybe the phone number. I have not written here phone number and some other attribute also. Customer have also these features, name, street, city. Is it not? Except that features, that is the common property is the name, street and city. Other than employee, another attribute is their salary. One of the descriptive attribute, that is the salary. But rather than in case of customer, there is no salary attribute is there. Here maybe the credit rating is there or credit index is there. Okay. So there may be possible this employee have different category, maybe the officer rank, tailor rank, and secretary rank, maybe some other also. Okay, if you can think this is a nested or some nesting of the generalization and as well as the specialization. Okay, so here officer have the another attribute, office number. You can see the officer, just a minute, I change the color of the ink. You can see this officer, tailor, and secretary. These three entity sets have the common features. What are the common features actually comes from the employee. What are the features of the employee? Salary, and as well as the features of the here person. What are the features? This one. That is the officer, tailor, and secretary have the common features. What are the common features? Salary, name, street, and city. Okay. And with these common features or common attributes, officer have some descriptive attribute, say office number. Say secretary have some another attribute, say hours worked, and so on. Okay, this is just idea how you can represent the generalization and specialization. Okay. Now design constant on this generalization and specialization, the constant on which the entities can be member of the lower level entity set. That may be condition defined. Suppose the condition is all the customer over 65 years are member of the senior citizen. Senior citizen is the, of course, what senior citizen is the one of the lower level entity set. Is it? Nah? So this lower level entity set, what is the condition for that? The age is over 65 years. That is a condition defined. And constant on whether or not the entities in the higher level may belongs to the one or more lower level entity sets or not. Example, suppose here this vehicle, suppose in these vehicles there is a number of vehicle entities there for each of the vehicles. Is it not? Now question is, each of the entity of this vehicle entity set are member of either car or truck, or there may be some entity in the vehicle or some vehicle is there that vehicle does not fall in as a car and as well as a truck. You understand my point, or you got my point? That is the participation. All the vehicles entity in this vehicle entity sets are participate either in the car or in the truck, or maybe if all the entity of the vehicle are participate or present in the car or truck, then it is a total participation. If there is some vehicle entity or some vehicles are there, that vehicles is not a type of car or not a type of truck. So what is the meaning of that? Such vehicle entity not belongs to car or truck. So at that time, the participation of the vehicles are partial. Okay.
Sir, didn't understand. So could you explain again?
Understand? Suppose this one. It's better here. Say this vehicle. Okay. Vehicle is the one of the entity, is it? Yes or no?
Yes.
Vehicle is the one of the entity. So in the vehicle entity, there are a number of entities, vehicles entities there. Entities are there, number of entities are there, distinct. Is it? Now question is, each of these either present in car or present in truck. If all of the vehicles entity participate in the lower level entity set, say car or truck, then that participation is called the total participation. That is the what is the meaning? The all the vehicles participate either as a car or either as a truck. Is it na? That is a total participation. But there may be possible that all of them are not participate. Suppose this one and this one, these two entities of the vehicle. That means two vehicles. These two vehicles are not present either in car or in truck. It is not there. It is not there. So what is the meaning? That is, in this vehicle entity set, all the entities are not participate in the lower level entity set, car and truck. Some of them participate, some of them not participate. So at that time, this participation is the partial. Okay. So either complete participation, total participation or partial participation. That is, entity must belong to one of the lower level entity set. In case of partial, entity need not belongs to one of the lower level entity set.
So what was the previous point, sir? Like in the so constant on whether they may belong or more than one in a single generalization. So I didn't understand that, sir.
Now in this example, it is not there. But if suppose the person is there, there is a category is the senior citizen. Okay. So if senior citizen or maybe the customer is the senior citizen, if that again another lower level category is there or lower level entity set is there, senior citizen like that, then which person will be fall in the senior citizen category? That is a condition defined. That is, those are actually above 60 or over the 60 years. Sorry, 65 years. Say here in this example, they can present that entity is that person entity is present in the senior citizen lower level entity. Okay, that means the here it is not there, but still I try to. Suppose here actually the maybe the customer. In customer there may be possible the senior citizen and non-senior citizen. Is it okay? So
yes, sir.
The customer may fall. That means here is A is there. Is A. Okay. This is actually I think is A. Okay. Basically this one. So this is a senior citizen. Senior citizen. Okay. So this customer entity, one of the customer entity may be present in this senior citizen if the condition is satisfied. Or maybe there is no condition is there. They can fall directly. Okay, these are the different category. Means these are the very advanced or very crucially if we think like draw the ER diagram, then that things actually comes. Another one actually, the another constant is whether or not entities may belongs to entities in the higher level entity set, of course, belongs to more than one lower level entity set. Okay, so if it belongs to more than one lower level entity set, then it is called a overlapping. That is, entity can belong to more than one lower level entity set. But if the particular entity of the higher level entity set is present only on one of the lower level entity set, then it is called a disjoint. So at that time, we can represent this one is a disjoint. Let us suppose here the person. You can think like the person. Some of the persons are employees, some of the persons are customer. Is it? There may be possible the person, particular person, say name is the say Osit. Say street is the say the what is the NG Avenue. and city is the, say, Durgapur. Okay, this is the person, name is the Osit, street is the this one, and DGP is the city. This person, suppose this person present in as an employee in the, say, bank. Okay, that employee Osit may be a customer of that bank. It is possible, na? He is an employee. He may be one of the customers. Maybe a saving accounts or some loan accounts are there. So what happens? This information, that is that these entities present in the employee as well as present in the lower level entity set customer also. That means OSIT is a present in the both the lower level entity set employee and as well as the customer, but not for all the person. There may be some of the person present in the employee, some of the person present in the customer, but there are some of the persons are there like OSIT, they present in both the lower level entity set. If it present both the lower level entity, all the lower level or more than one lower level entity set, then it is called the overlapping, this one. Okay, and if it is not the case, that means the particular entity of the higher level entity set is present only one of the lower level entity set, then it is called disjoint. If it is a disjoint, that can be reflected by the this symbol is, not only is a disjoint. I think it is clear. Is it okay? Disjoint and overlapping?
Yes, sir.
Constant. Now, I want to go to the another important feature. These are the basically advanced features of all of these are advanced features of the ER diagram or entity relationship model. Now, this is a in figure. Actually, I think the you see the slide number 48. Is it okay? Aggregation.
Yes, sir.
Which, okay. So what you see? One of the ternary relationship. What is the ternary relationship? Name of the ternary relationship is the work on.
So
This work on relationship. Please, pardon me.
Sir, I thought you were asking the definition of a ternary relationship, sir.
No, means I think this picture actually what actually demonstrates this is that work on is the ternary relationship. This work on relationship associate the three entity set. What are the employee, branch, and job? I already discussed this ternary relationship again. Yes, no, that is the employees work on a branch, maybe one branch or maybe more than one branch, and do the any number of job, because all are actually many type. No arrow key is there. If arrow key is there, then there is a at most one. But here arrow key is not there, means any number 0 to n. The meaning is, I think, clear because that ternary relationships I already discussed in previous case. So now, suppose I want to add one of the point. What is the point? We want to record managers for task performed by an employee at a branch. That is here, the concept of manager is not there. But if we introduce that, of course, in an employee manager is there. But in this diagram, it is not reflected. But if we want to record the managers for the tasks performed in a particular branch, say My College branch or maybe the Benachiti branch. So for that, actually, what we need? We need another entity set. We need another entity set. Say manager entity set. That manager entity set, it's better actually we go for the next diagram. That means for our normal concept, what we learn up to that, we can create the one of the manager entity set and one of the relationship set. What is the name of that relationship set? Manages. That is what of the name? Manages. This manages, you can see here this relationships associate how many entity set? It associate employee entity set, manager entity set, branch entity set, and as well as the job entity set. Okay. Why it is required? Because till we have no idea or no concept is present, there is a the relationship, whatever we discussed are already, the relationship is valid for a two or more entity sets, but there is a no concept of relationship among the relationships. You got my point? The relationships means here relationships between the two entity set, that is the binary relationships, or maybe more than two relationship, that is a either ternary or maybe the in this example 4. So but there is a no point or no way we can relate or we can draw a relationship among the two relationships. So for that actually we can create the two separate relationships here. Okay. But here actually these relationships set work on and this manages. Just I change the color. This work on relationships and this manages relationships contain some overlapping information. What are the overlapping information? Some overlapping information.
So
Every manages relationships correspond to and work on relation. That is the whatever present in the manages that also present in work on. You got my point? That is every manages relationships correspond to the work on relationships also. In work on there is a employee, branch and job information is there. In manages that same employee, branch and job as well as the manager is included there only. But the except manager, other three information, employee, branch and job is already in work on. That is every manager's relationship correspond to the work on relationship. But every work on relationship associate or correspond to the managers? No. That means there is a some of the employees are there, those are not managers any job. They can just simply work. They can simply do some job or have some responsibility in a particular branch. Is it not? So that can be reflected by the work on. That is work on relationship. There is a some of the work on relationship, some of the work on relationships may not correspond to the any manager's relationship. So we can't discard the work on relationship also. That is both the relationship is important here.
Sir, one question, sir. In
All
the
of you
previous
got
diagram.
all of you got my point? Please pardon me question.
Yes, sir. Sir, in the previous diagram, sir, like one slide before, sir.
Okay.
Sir, is the branch name and
This is a
employee
ternary.
ID? Sir, is the branch name and employee ID partial keys, sir?
Branch name is a key of the branch entity set.
Sir,
Employee
it was
ID is a
partial
key
key,
of the
sir.
not a partial key. It is a primary key. Candidate key and as well as the primary key.
Oh, acha. Okay, sir.
You try to understand in this diagram, in this page, what are the ternary relationships work on among the employee entity set, branch entity set, and job entity set. These three entity sets. This does not reflect the managers. Manager means what? Record about the managers. Okay. If we incorporate that fact, for that we need to be one of the entity set manager and another relationship managers. This relationship associate not only employee, manager, and branch, as well as it also associate with job by this line. Okay. But point is, whatever actually I discuss here, the point is if we consider or if we introduce, say if we introduce this manages relationship set, then at that time we omit the work on. We can discard the work on relationship, because here you can see here manages relationship is not there. For that work on is of course fine. But when we add another relationship here, example manages, this manages you can see it associate the employee branch job also. Whatever the entity set associated by the work on relationship, three entity set job, branch and employee, this three entity set is also associated by the word manages. So we can discard work on, or it is required. Still it is required. Why? Because the every manages entity, relationship, every manages relationship is present in the work on, but not all the work on relationships are correspond to any manages relationship. That is, there may be, for example, there may be some of the employees are there, they does not manage the things, but they can do some job in a particular branch. Okay, in a particular branch or maybe more than one branch, but they are not related with the to do managers like. Okay, so there may be some of the employees are present, they are not related with the managers or manager. So at that time, for this purpose, the work on is the required. That is the in the work on, in this relationship, this work on relationship, there is a number of relationships are there. Some of the relationships, suppose this relationship, say this one, these are present in manager. Sorry, not managers. These are present in this managers, and as well as present of course in work on. But this one, all of these are actually present. These are not present in managers. That is, this cross relationship, this relationship, this one and this one, these three relationships are not present in managers relationship, but it present in work on relationship. Okay, that is, not all the work on relationships correspond to the managers relationships. Some of the work on relationships correspond to the managers relationship, but all the managers relationships, that is the every managers relationships correspond to the work on relationship. Okay, so this means, that means there is some redundancy, is it? No, we can't eliminate the work on, and also we can't eliminate the managers. So how we eliminate this redundancy? By the concept of aggregation. Okay, in case of aggregation, in this aggregation, by this concept, we treat the relationships as an abstract entity, allow relationship between relationship. That is, here actually the above one, that is the, you can see like this previous picture, it will be better. Oh, sorry, it is this picture, this part, we can aggregate this part, and we treat this one, which one? This job, employee, branch and work on, we aggregate this one and treat this one as a one of the distinct entity set. Okay, distinct entity set, just like this one, you can see, just like this one. That is, work on relationship, employee, job and branch, this can treated as a this is the aggregation, and this is actually called say name is the, say, work on entity set. This is a one of the entity set. Okay, and this is another entity set. This is another entity set manager. So both the entity set are associated by the managers relationship set. Okay. So without introducing any redundancy, this ER diagram, that is this ER diagram, an employee represent the employee work on a particular job at a particular branch, and employee branch job combination, that is the employee branch and job, this combination, that is the, this is the one of the entity, this work on entity may associated with the manager. You got my point, na?
Yes,
I
sir.
can again repeat.
So
I can
is
again
work
repeat
on the
this
name of the
picture.
aggregated entity
This is
set, sir?
this work on, that is the this box. Just I change the color. That is this box. This is the aggregated part. This is one of the entity set. Though this entity set consists of another 3 entity set, employee, branch, job, and which is associated by the work on. But logically, these things we can, just like we can think like it is a encapsulated or aggregated and treat like a one of the relationship, one of the entity set. What is the name of the entity set? Work on. The same name of the relationship set. Now, this actually associated with another entity set, manager, by the managers relationship. Okay. Now you can see just like this one. Suppose this is one of the entity set and this is another entity set. Whatever the name, say XY, and this is a AB, ABC and XYZ. Say this is a one of the relationship. If this is the relationship, then what is the meaning of that? This relationship are associate XYZ entity set and as well as the ABC entity set. There may be any number of XYZ entity set is associate any number of ABC entity set. Any number means there include 0 also. Is it na? Yes or no? Any number means 0 to n number. If suppose there is a arrow key is there, that means this is a M side, this is one side. What is the meaning of that? The any number of XYZ can associate at most one ABC entity set. Is it? You agree or not?
Yes, sir.
So at most one, there may be 0. I am not saying about the total participation. If we are saying about the total participation, then every entity set are participate. So here may be chance some of the ABC entity set is not associated with XYZ or maybe associated. So similarly, you can think this box, this blue color box, this is the aggregated entity set. Here, maybe some of the entities are associated with the manager entity, and some of the entities not associated with the manager. Those are not associated with the manager. They can associate inside that structure. They can that employee associate with the branch and job also by the work on, but they are not associated with the manager. But some of the entity of here associate with the manager. Associate with the manager by managers relationship, but they also use the internally work on relationship to associate with the branch and associate with the job. Okay, so this is the aggregation concept.
Sir?
You please tell me.
Sir, if manager is also related to work on, then we could have removed anyone among work on or managers.
No, manager, you don't. You just confuse because I know that this is some complex thing. If you think this diagram, you can see here. This manages this relationship associated with how many entity set. This manages associate employee, manager, branch, as well as job, all the four. Is it?
Yes,
So
sir.
managers means he also associated with the job. Here you can see, suppose I change my color. Just a minute. Suppose, say, this work on entity. Suppose these are the entity. This is one of the entity. This is another entity. Say this is another entity. This is another entity. Say 5 entities there. That means 5 employees are there. Okay, you got my point. 5 employees are there. Suppose among the 5 employees, these are present or associate via work on relationship. Is that clear?
Yes,
All
sir.
of these 5 entities, that is the 5 employees, associate with the work on relationship, that is that employee associate with the branch to do some job. But here some of the entities, say these entities and say these entities. These two entities are also associated with manager by the managers relationship. Okay, what is the meaning of that? This black color, these two entities are also present here, also associated via this work on relationship, as well as use the managers relationship. Okay, that is, some of the entities in the abstracted this entity set are associated with the manager and some of them not associated, but they are associated with the branch and job inside this work on relationships. Similarly, the similar type of another example. Time is, your next class is there, na? Say one of the entity sets, say employee.
Sir, we have a class now, sir.
Okay, just 1 minute. Okay, suppose the name, for simplicity purpose, we can consider the true attribute. ID, employee name and employee ID. Okay, suppose the project is the another one. Here say project number is there. This is the one of the attribute, and say this one actually relate with the, say, work relationship. Okay, suppose here descriptive attribute, say hours is there, that is in the relationship work. Now I think it is fine, the employee can work in a particular project. This is the project number, and how long, that can be described by the hours. Okay, but here actually it is not mentioned the, if we want to incorporate the fact the employee use a number of different machines for this project, if we introduce that fact, so that is not reflected by this. So machine means need to be create one of the entity set machine, or say machinery. Say here machine ID is there. Okay, some other attributes are there. For simplicity, I have not considered this one. And here users is the another relationship that can relate the employee, project and machinery. Employee, project and machinery. Okay, so you can see here the similar thing happens, whatever we discussed just before example. The sum of the all the uses relationships correspond to the all the users relationships correspond to the these users relationships correspond to the work on also.
Yes, sir.
Sorry, work relationship. That is, it is present in the work also, but not all the work relationship is associated with or correspond to the users, because there maybe some of the employees there, he or she engage in some project but not use any machinery parts. Okay, so such employee not associate with the users relationship set. Is it clear? So this fact here, some redundancy is there. What is the redundancy? The all the users relationships present in the work on, but not all the work on. Some of the work on relationships are not present in the users. So we can remove this one. How? By the concept of aggregation. That is the higher level. This one actually we can create a, that is just a minute, employee project. This is these two entity sets are related with the work. Okay, and here hour is there. So this part actually we can aggregate, or we can abstract it, and we can think this is one of the entity sets, say work entity set. Okay, now this work entity set is associated with the users relationship, and users actually associated with machinery entity set. And machinery, of course, the machine ID is the one of the attribute. Okay, so now we reduce the, we overcome the redundancy problem. No duplicacy is there. You can see, think like just previous discussion, that is some of the entities, that is some of the employees, say this one and this one, and say this one, these three are, sorry, these three are correspond to users, that is the, they can use some machinery parts for that project. Okay, so that things are actually that can done internally by this, and those are actually not present in a machinery. These are do the work by the internally, this work relationship. Okay, so these are the concept of aggregation. So in the next class, actually tomorrow, I can just discuss how this ER diagram is. The lot of things we discuss in a ER diagram. Now how we can convert this ER diagram to, or ER data model to our relational data model, because we can mainly concentrate or focus on the relational database that are the important in real world. So how we model from this ER diagram or entity, and as well as the relationships, how we can convert this one in a table, that is in relational database, data are stored or represented in a table. So how these entity sets are converted in a table, how the relationships actually convert in a table. Similarly, how this aggregated or aggregation type of entity sets convert in a table, and as well as the weak entity set or strong entity sets, how we can convert in a table, what are the columns on in a table. We can discuss this one in our next class. Okay, do you have any question, please?
No, sir.
Am I audible?
Yes, sir.
Okay, I know that this portion is a little bit abstract, and as well as the advanced portion, but hope you understand, and if you have not clear, then you can read from the books or maybe from slide, and still if you have a problem, then we can discuss maybe in some later. Okay, so you have a class. Sorry, you may leave from the class. I can consider the attendance. Okay.
Thank you, sir.
Thank you, sir.